All right, today we're jumping into a real mathematical detective story. And our main subjects are these two numbers, 28,757 and 24,257. Now, on the surface, they're just numbers. But as we're about to see, they've got this hidden relationship that's all tangled up with prime numbers, chaotic spirals, and, well, a shared destiny.
And that question right there, that's the central mystery. It's a total paradox, right? How can two things be so fundamentally linked, but at the very same time be heading in completely different directions, forever? To figure this out, we're going to treat these numbers like characters in a story and uncover the hidden forces pulling the strings.
Okay, so let's meet our two main characters. On one side, you've got system 24,757. We're going to call it the negative system, and you'll see why in a bit. It looks like this dynamic, swirling spiral, kind of complex, kind of chaotic. Then you have its partner 24,257, which we'll call the positive system. And it is the complete opposite, a stable, predictable, rigid anchor. So the mystery just gets deeper. How can these two be part of the same thing?
To crack a case like this, we're going to need a special tool. It's called the 36 modular grid. The best way to think of it is like a number spectroscope, a device that can take all the static and noise of the number line and reveal these beautiful hidden patterns inside. So how does this grid work? Well, it uses something called modular arithmetic, but don't let the name scare you. It's basically just clock math. Think about it. If you start a task at 10 a.m. and it takes 4 hours, you know you'll finish at 2 p.m. Your brain doesn't think 10 plus 4 is 14, it just naturally wraps around the 12-hour clock. All you care about is that final position. And that final position, the remainder, is what this is all about. It's an amazing way to find hidden cycles. And here's where our 36 grid gets really powerful. When we use this clock math with a clock size of 36, something incredible happens. That infinite, seemingly random sequence of prime numbers, it suddenly gets sorted. Every single prime number bigger than 3 is forced into one of just 12 possible channels. The chaos gets organized. And here they are, these 12 channels. These are the only paths a prime can travel in our system. It's like the grid acts as a prism, splitting the primes into a predictable spectrum. Now for our first big break in the case. We take our two numbers, 28,757 and 24,257, and we run them through the grid. And what do we find? Get this. They both land in the exact same channel, channel 29. So, despite looking so incredibly different on the outside, they share this deep, fundamental connection. They're locked together on the same wavelength. Okay, let's start digging. We'll open up case file 1, the chaotic, spiraling negative system, 28,757. We got to look under the hood and see what makes this thing tick. You see, every number like this has its own unique fingerprint, its own DNA, made up of its prime factors. For 2875, that DNA is 149 times 193. These two prime numbers, they are the absolute core building blocks that define everything about it.
Now, this system has this really unique internal process. At each step, we apply an operation, and the remainder gets passed to the next step. And you can see what happens. The number just dynamically shrinks. It's not a straight line down, it's more like it's converging, zeroing in on a specific destination.
And here's where it ends up. After just 4 steps, the process doesn't stop at 0 or 1. No way. It lands squarely on 149, which, if you remember, is one of its own prime factors. It's like the whole process was a search algorithm designed to find a piece of its own DNA. It's a journey of self-discovery.
So, we've got this dynamic system that literally hunts for its own factors. Now let's turn to its partner, the stable anchor, 24,257, and see how its story holds up. Is it doing the same thing? First things first, let's check its DNA. The prime factors for this one are 127 and 191. Now 127 is interesting. It's a special type of prime called a Mersenne prime, and they're known for creating super stable, predictable patterns. So that might just be a huge clue as to why this system is so rigid. So, we run the same recursive process on this system, and we find something completely different. There is no dynamic countdown. Instead, at every single step, we get the exact same result. The difference is always unwavering -319.
I mean, talk about a total 180 from the first system. Instead of a dynamic, shrinking search, we have this fixed, static rhythm, this constant difference of -319. It's like the steady heartbeat of this stable system. But does it also lead to self-discovery?
Turns out, yes, it does, just in a totally different way. A simple final calculation using that constant difference reveals the number -127.
And there it is, the negative of its Mersenne prime factor. So it also finds its own DNA, but not through some chaotic search. It does it with a stable, predictable formula.
Okay, so we've got all our clues on the table. One system is a dynamic hunter. The other is a stable calculator. They're connected by that shared channel, but they operate with completely different internal logic. It's finally time to put it all together and solve this thing.
This table just lays it all out, plain and simple. You can see the opposition at every single level. Different kinds of prime factors, dynamic versus constant logic, a spiraling cloud versus a straight beam. It's these internal differences in their DNA that create their totally different personalities.
So you might be wondering, why? Why are they so different? Well, it really boils down to their internal clock speed. The positive system, with its stable Mersenne prime, has this incredibly fast cycle. It repeats itself every 7 steps. But the negative system, it takes nearly 150 steps to complete one full rotation. It's so much slower.
And this gives us the absolute core of their relationship. The positive system is like a lighthouse, blinking predictably with its fast, stable cycle. And the negative system, it's like a ship on a long, slow, kind of chaotic orbit around that central light.
So now we can finally answer that question we started with. Where are they going? Well, their journey is one of divergence. Way back in the past, with smaller numbers, they looked like a single, unified thing. But right now, we can see them starting to pull apart. And in the future, as they get bigger and bigger, they will fully separate into this stable, beam-like core surrounded by a diffuse, spiraling cloud. And there it is. That's the solution to our paradox. Their shared address in Channel 29 acts like a kind of gravity, tethering them together forever. But their wildly different internal clocks, one ticking super fast, the other incredibly slow, are pulling them apart into 2 completely different geometric fates. They are connected, yet they are absolutely destined to drift apart.
And what's that final destination? Well, it's not some victory for pure chaos or a triumph of perfect order. As the source material puts it so well, the end of their journey is a fractal dance, a state of beautiful, mind-bending complexity where the stable beam and the chaotic cloud just coexist in this delicate, unending balance.
It really makes you wonder, doesn't it? If just 2 numbers can hold a story this complex, a story about gravity and time, chaos and order, what other hidden stories are just waiting out there for us, coded into the secret language of math? Thanks for exploring this one with us.